All right, for all those people that are finally ready, DJ is not ready. DJ, get your life together. What is wrong, DJ? Thank you very much. All right, class.
Yeah.
Thank you. All right, now we're going to go through, and I need you guys following along, pay attention, because this is what makes it difficult. This is the hard part of the unit. This is why I saved this for today. Are you ready yet? Are you sure? Thank you. Good. Now, the probability with events that are not mutually exclusive. Here an example of a non-mutually exclusive. If I say a king or a club, how many kings do we have? 4. How many clubs do we have? Clubs? Remember, it's
4. No,
there's 13. There's 13 clubs.
Right.
There's 13 clubs. If you're looking at the chart, there's 13 clubs going all the way across. Now, but the problem is they're not exclusive. Yes.
Can I get
You mean the one up here that I already asked everyone about? But you had earbuds in and you weren't really listening to my instruction. Anyway, all right, so now, if you are looking at your deck of cards right now, look at the clubs. If we have 4 kings, and we're looking at the clubs also, isn't one of those kings also a club? So wouldn't that king be counted twice? It'd be counted once as a king, right? So the king of clubs is counted there. So I have 4 of those, but then there is 13 clubs, and one of those clubs is also a king, isn't it? So that means there's overlap in between those two groups. That is what it means by not mutually exclusive.
Right.
Just like we can't have, so when we did our warm-up today, we had 10s and kings. Is it possible for a king to be a 10?
No.
No. Those are exclusive. They can't be together. They're completely different. But this are not mutually exclusive events. So now, this is if A and B are not mutually exclusive events, then the probability that A or B will occur is determined by adding their individual probabilities, then subtracting probability that A and B occur simultaneously. So, it's going to look like this. I did the notes from last time, right? This is the same thing we did. A plus B, right?
Right.
Probability A plus probability B minus probability of A and B. This is where do they intersect? So if this was a Venn diagram, I would have that group over there, I would have that group over there, and this piece right here is my and statement. So where do they overlap? So in that analogy that we were talking about, a king and a club, how many overlap? 1, right? 1 is a king and a club. Does that make sense? It's a king and a club. So I would subtract that and statement there. Okay, let's. In a group of 25 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy doing both. Okay? And most of them are in this class.
Horrible analogy.
I know, we got screaming baboons over here. Okay, so if one baboon is selected at random, find the probability that enjoys grooming its neighbors or screeching wildly. Okay, so I know we got more screeching wildly going on back in here too. I know, as he keeps, shouting out stuff. Anyway, all right, so Venn diagram. The Venn diagram first is, okay, my first group. I have 18. Okay, 16 screeching wildly. And right here we have 10 that fit both categories.
Yellow.
Jacoby.
The coaster.
this is the Venn diagram for this. Okay? I tried to actually show what this is going to look like. So, this is my A, this is my B. So the probability of A happened. So probability of A plus probability of B minus probability of A and B. Another one of these damn things. Okay, probability of A. What's my first group?
18.
18, and my total is 20 what?
25.
Okay, 18 over 25 plus 16 over 25 minus. She wants the 6. It's on the box.
18.
Okay, so now what is and? What is in both groups? 10. This is my both groups that I'm looking for right here. So this is my both groups category. So it's only going to be 10 out of.
So basically 25 over 20. Oh.
Does that make sense now? And that's where this here comes from, because we have 10 of them that overlap.
Okay, I think it's just the A and the B.
I know, and that's why I try to draw it out, and I'm trying to explain it in great detail. And I'm trying to do my best to explain it because I already know this is a difficult concept. That's why I started just today instead of doing it on Monday, where we had 42 absent students in my, second hour.
42.
Do you even have?
No, we don't. I'm being facetious. Anyway, do the math.
Jesus.
Wow, can't you? Okay, anyway. So, that's going to give me how many?
24.
What is it?
24.
24, because I add these together, minus 10, right?
See.
So the probability of this occurring is going to be 24 over 25. Go ahead, divide it out for me, and I'm going to get a, yep, 96. Is it 96 exactly?
Yeah.
Yeah, 96 exactly percent.
So this. It's not working for the question.
Is it pertaining to this?
Yeah, but I can live with that.
Why?
Next.
It's all right if you want to ask questions, because other people are still, this is not the easy part. That's the reason why I'm trying my best
No, it
to.
was just about this, the box at the bottom after this, like the blank one.
Just the what?
The blank one after this one.
Oh, the blank one after this?
We'll just continue.
Oh yeah, just continue. All right, so let's keep going. Probability to odds. If we know the probability of event, we can determine the odds in favor or the odds against of event. The odds in favor of event E are found by taking the probability that E will occur divided by the probability that E will not occur. Odds in favor of E. Okay? So it's going to look like this. Okay? So I have the probability of this happening. Didn't we have an analogy on this the other day? Like the odds of someone passing?
Like OJ? Sorry.
Why would OJ pass?
He died today.
He did?
Yeah.
Oh, dang. Okay. I guess the juice is loose. Anyway. Alright. So, the probability, I believe we were talking about someone passing class, there was like a 41%, right? Something like that. It would, Anyway, so if it was 41% of passing, out of what would be the probability of not passing?
59.
59. And then we divide that out. We have in favor of, and then if we do against, the against happening, that would be 59 out of 41.
We should write that, right?
I don't know, maybe?
We should write that down.
Okay. Okay, you roll a single 6-sided die. Find the odds in favor of rolling a 2. So I'm gonna write the set first. 1, 2, 3, 4, 5, and 6. So the odds are different. Okay? The odds in favor of this. How many 2s do we have?
One.
1. Okay? So the probability of that would be 1 out of how many?
6.
Divided by the probability of not. How many are not 2s?
5.
There's 5 that are not 2s. There's 5 that are not 2s out of 6. But since we have a fraction over fraction here, I'm going to multiply by the reciprocal, which is going to look like this. It's going to be 1 over 6 times the reciprocal, which is 6 over 5. I take the reciprocal of the bottom. And what happens here? I get 1 out of 5. Isn't that the same as saying how many in favor? Okay. How many 2s did we have? We had 1, 2. And how many were not 2s?
5.
So it's the same thing as writing it like that.
1 over 5. 1 out of 5.
1, okay, 1 to 5. You write it as 1 to 5, or you write it as 1 to 5. Those are odds. So, let's say if you're betting on the Super Bowl, okay? Oh my goodness, just put it right there with the rest of the pile. So, if you're betting on the Super Bowl, if you guys remember back when the Super Bowl was happening, I think when the odds makers, they were saying, hey, Kansas City Chiefs are the favored to win. This is what they're referring to as odds makers. The people that would actually go through, they would have the chances, so that means it was a more chance to win, so it's a bigger number on top over a little number. And so when they are doing that, those bookies, they do this knowing that they're going to make money no matter what. But then if they put the odds off too much, then if there's an upset, you're not, they're going to lose a whole lot of money. But if there is a blowout and everyone is actually voting the other way that they are going to win, then it goes the other way. So when you actually talk about this, odds makers on sports betting, it's actually a huge industry. If you ever watch a football game anymore, don't they have like all commercials all the time about, Betting Kings or DraftKings or all these others where you could actually go and bet on the games during the game? Okay, those people are actually making buku bank. Those people actually are in there making these odds and making money. Okay, odds to probability. If the odds in favor of an event E are A to B, then the probability of the event is given by, so odds to probability, okay, it's going to look like this. It is A, okay, in my case, okay, what was that A on that last problem? It was 1, right? Okay, 1, and on the bottom was 5, right? So it'd be 1, A is 1, plus 5. What the probability of event happening was 1 out of 6. Because there was one number 2, right? There was one number 2 out of all 6, isn't there? That's what that means. The whole thing, we're converting it from probability or back and forth in between odds and probability. the odds in favor of a particular horse winning race are 2 to 5. Okay, what's the probability? These are in the odds. So if my odds, my A is 2, my B is 5. So if I'm going to write this as a probability, it would be the probability of whatever happening, let's say E, event A, which is 2 over 2 plus 5. Because there are 7 total, it's out of, so it's 2 out of 7. Does that make sense or is that nonsense? Somewhat?
Follow the formula.
Every single time. And so on these ones right here, you have to be specific if you're referring to odds or probability, because yes, they sound the same, they're used similarly, but they are slightly different, and converting from one to the other, you got to pay close attention. Did you get it? Okay, good. It's almost like I have a YouTube video for this whole thing, but you know, ain't no one ever want to watch those.
That's
There we go.
allowable.
Okay. That being said, all right, everyone's going to make sure that they got like, share, and subscribe. Work on this homework. This is key. Now that you currently have this in your brain, go do this right now. Okay, even if you're working on all this other crap, go do this right now. If you're doing makeup work, work on that advisory after school. Go work on this one right now.